Hi all, welcome back to the next video in the Crazy Small Computer video series. I think it might be the last one where I actually get to do some wiring because last time we did the yellow wiring, the address lines from the program counter into the ROM chips and then out to the RAM chip. And in this video I've put in the control lines that go out from the Control ROM out to the various parts of the CPU. I also just want to show you how I've done the ROM chip mount. So I've got a ZIF socket, and underneath the ZIF socket I've got an IC socket, but that didn't seem to give me enough strong legs to go into the breadboard, so I've actually got some pin headers as well, and that's actually quite useful because with that extra vertical height it helps lift the ZIF socket up above the address wiring. I'll leave those out because it also helps me show the lines, which are the control lines. So I just quickly go back to the logical diagram of the CPU. We've got things that we need to control. So we've got the two registers and we need to have control lines so that they get loaded when we need them to and not otherwise. We've got the ALU, and of course we need the lines for the ALU operation to go in. When the ALU is writing output, we need to be able to tell it to output its data onto the data bus and to write that into RAM. And at the same time that it's writing its output to RAM, we also need to make sure that the flags register captures the latest value of the flags. And of course when that's inactive, we need the RAM to output values that can go into the multiplexer and that can be loaded into the two registers. What else do we have? Oh, we obviously got to have to control the multiplexer. So we've got the A cell line that either chooses to input from the data bus into the registers, or some of the control lines to act as constants to be loaded into the registers. And finally we've got the line that increments the program counter, or alternatively when that's off, to load an address from the address ROM so that we can jump to a new instruction. Alright, so let's see how they're laid out on the actual board itself. So these three lines that come from this side of the control ROM are the three ALU operation lines. Now remember, we've actually got 16 operations, so that's only 8 because 2 to the power 3 is 8. We're also going to use the A cell line when it's not being used to control the multiplexer. We're going to be using it to give us an extra bit into the ALU to give us 16 operations. Okay, so that's 1, 2, 3 out of 8. The next one is the PC increment line. So that comes out of here, goes down to control both the top and the bottom program counter chips. Next one I think is B load. Comes out of here, goes down and controls the loading of the B register. Next one to that is A load, and that controls the loading of the A register. Next one up I think is the A cell line. Yep, looks like it. It comes out, goes over and controls the multiplexer, and then pops up and goes over and acts as one of the extra bits for the ALU operations. And finally the RAM write line comes out of here, goes over and controls output enable on the ALU, controls the loading of the flags register, and from there it also goes loads flags load over there, and it also goes and controls the write enable on the RAM. Why I got confused by this wire is we also need to bring out the carry of the flags so that we've got carry in going into the ALU. Excellent. So you can also see that I've wired up lots of LEDs, and there are pretty much no control lines left that I have to jiggle manually. I think the only lines we have to jiggle manually now are either to have the timer giving us a monostable or the regular clock pulse, and I've got the line which resets the program counter back to 0. So those are the only two lines I really have to toggle now. And a couple of hours ago I managed to actually load up a program into the two ROMs and single step it, and actually the CPU is working. So in the next video I'll step us through running the Fibonacci program with just 2 decimal digits. Okay, so that's enough for now, and I'll see you on the next video, and hopefully the lights will be lit up and you'll see it in action.